All right, so welcome to the North Wing. In the North Wing, we're going to be taking a look at if-else patterns and what they look like. There's two primary patterns that we're going to see that are correlated to if-else statements. One of them looks like a set of stairs, and the other one looks like a ladder. They can manifest in multiple ways, meaning there can be like a legitimate list of if-else conditions that are nested together, or a bunch of ifs followed by a single else. And something else that can actually cause that is inside of a single if condition, if you're checking multiple things within one if condition. So example, we have a variable called age that's an integer, and you're checking to see if it's above 18 but less than 50 for some specific reason. That will end up looking like this ladder pattern. If you end up legitimately having an if condition, and then some else condition, and then some if condition, and some else condition, and all of that is sort of nested together, that ends up looking like these stairs. So rather than kind of focusing on these like slides, again, we're going to jump right into the application. Sort of remember before we were in this lobby, and the lobby had this switch case statement. And the first one was the North Wing. So let's go into the North Wing and take a look at what's happening here. This is a clear indication that we're looking at the stair pattern. And what this tells me is we're looking at code that has this nested if, else thing. And what happens is we're checking for some condition, otherwise we're doing one thing. And only if the first condition actually was matched or satisfied will we check the next condition. And only if those first two conditions are satisfied will we check the third. And we'll continue this process down and down and down. And each individual case will have its own failure point. That's all of these locations down here. The success points are all right here. There's another pattern that happens that doesn't exist in the sample that I've uploaded to the GitHub repo, but I'll show you how to generate it. It looks like this. These are the same exact functions. They're just developed slightly differently. And it looks kind of like, oh, okay, well, you know, I can sort of discern that these might actually be the same thing, even though they look sort of like wildly different. This is that ladder pattern. And in a sense, what we have is we have one condition that's checked for, and it'll fail out into a single failure point, or it'll continue going through all of these things in a chain here. So the difference between this particular pattern and this one is that this one nests each individual condition with a unique or its own failure case. So we end up having this sort of like pushed off to the side with each individual case right here. In any event, they both correlate to the sort of if-else conditions where we're checking multiple things, and if at any point we fail, we jump all the way down to an else condition and then exit out. Otherwise, we sort of continue on down this path, whether it's straight down like a ladder or straight down this way like steps. So what we want to do is, this is the actual pattern that we have compiled into the example one. And I'm going to come in here and again take a look at these calls. I'm not going to look at how everything is set up. I'm going to say that there's a system call. That system call looks like it has CLS. The reason why Binary Ninja doesn't show that to the side is because CLS is only 3 characters, not 4. It'll only resolve 4 characters or more for us. So if you highlight that, it'll show you a peek, a snapshot of what is over there. And obviously that's the string CLS. So we know that system is being called to clear the screen, and then it's printing out some stuff. And then we have fgets, which is going to get some input from the user, and then it's going to check that string length for something. It's going to compare it against 11. And what it's going to do is come over to this location and call this guy, set EAX to -1. So a bunch of F's is assigned decimal that equates to -1. And then it's going to come all the way down here and exit and leave. So one of the things that I'm interested in doing is understanding what this is. And it turns out that each failure case does the exact same thing in this stair pattern, this particular pattern. And it says the elf whistles suddenly. So let's see if we can get that actually to return. Let's type in 1 and describe what this wing is all about. It says, you enter the North Wing. You sense a themed Christmas party going on. Elves are walking around smoking cigarettes with bare feet and blood-soaked shirts. Strange. Your name, please. You look down to see a rather tough-looking elf with a clipboard and a short fuse. You'd better give him a name quick. What do we give him? Well, let's give him a name like John. Well, it says the elf whistles and suddenly the entire room stops and stares. You run in fear. All right. So that's the failure condition that we were actually interested in. And one of the things that we want to do is try to identify what is the correct condition that'll get us back to some good state, which is hopefully getting a key. All right, so coming back over here, we have some string length, a condition on string length to actually get into this. And then we start checking different cases. So this is where I'm actually interested and want to start looking at what's going on in each individual instruction. I've already sort of narrowed down some functionality based on a pattern, and now I want to go take a look at what will actually get me to a good condition. If I continue down this entire pattern, I'll see that it comes down to one unique call that sets EAX to 0 versus EAX to -1. EAX is the return value, by the way. So in this particular case, we click on this. It says, welcome to the party, nods in the elf sense of something. So this looks good. Like the welcome to the party, I want to be invited to this party. So I want to get to this location. So I can do Z north wing access granted or something. Again, that's not like this amazing function name that we can say. It's just something that gives us a breadcrumb that says, all right, I know in this particular function is related to the north wing, and it gives us access to something, some party, right? So if we scroll all the way back up to this original condition that'll get us here, and again, we want to traverse these steps, is the very first thing that we want to understand is that it is going to the base pointer, going 1C offset from that, which it calls var20. So this is a binary ninja thing that it does this. If you are looking in RadAir 2, or you're in IDA Pro, or you're in Hopper, or some other disassembler, you will see whatever it actually does, which is probably just a byte reference of just this. It won't specifically name what that is. So it's given this generic var20 name. It takes that byte and it moves it into EAX with a 0 extension. So what you end up having is if the byte is 01, you'll have 00000001. That ends up just clearing the rest of the EAX register. So this comparison is taking a look at AL, and the AL again is the low byte. So it's only going to compare that low byte against 4A. If we go to display as character constant, that's going to be a capital J. The reason why I know it's a character constant is because of ASCII encoding. It's just something that we've sort of seen a lot and understand. So in the handout of the materials for this particular workshop, if you scroll all the way down to the bottom, you can find these online too, is an ASCII chart. So in this case, when we think about ASCII characters as being 0 through 9 or capital letters and lowercase letters, we have a hexadecimal and a hexadecimal and a decimal representation of that. So a capital J is 4A hex or 74 decimal. So you'll start to realize after a while when you see references to specific bytes or specific ASCII values, you'll be able to ask yourself, is that an ASCII range? And you'll think about this 20 hex all the way up to the 7D or 7E. Everything else after and before that point is either not ASCII or it's one of these character control feeds, control sequences. So everything within this section here is really what we're interested in. And it's sort of like this sort of hunch that you have where it's are we comparing this 6F, is that an ASCII range? And then you can end up just sort of displaying it as a character constant. So what we can end up doing is going down this entire pattern here and figuring out what it's checking against. And again, each and every one has to be the same. So what it's doing is going to the location on the stack, and it's pulling off the value that we entered, which is considered var20. Then it'll go to var20 plus 1 for the next character, and then var20 plus 2, and then plus 3, and then it stops after that point and then defines a new var. Why is that? Well, because we're dealing with a 32-bit architecture, each register or each spot on the stack is 4 bytes. So if we do this particular reference, we can start at the first byte in that D word and then go to the second, third, and fourth, and then we define a new slot or a new section within that, which is another D word. And then we go 0, 1, 2, 3, reset 0, 1, 2, and then so on, right? So just an odd sort of characteristic, but bottom line is we can still do this 1A, 19, 18, 17, 16, 15, and then continue that path. So we sort of understand that we're sort of indexing into the same string. And if we continue to keep doing this with these character constants, we'll see that, at least in the beginning, it's JOHN. Now, I can already see a pattern, like what's the best Christmas movie ever made? And you might think, a name of a person who's walking around smoking cigarettes in bare feet in blood-soaked shirts. It might be John McClane. So we type that in and it says, "Welcome to the party," the elf says, as he slips a key into your coat pocket. All right, now we head back to the main lobby, and now we have one key. So we have accomplished the task for the North Wing, which is to gain entry into the elf's exclusive party and get a key. Now we are one step closer to getting to Santa's secret lair and getting access to his vault and his list. And we were able to do that by understanding this particular pattern and knowing where we need to go. We continue that down, we'll see the same pattern with John McClane. Any of these points where it says, like, if we type in one particular character wrong, it's going to come down this path and then branch off and fail. So that's certainly something that we don't want to do. As far as the other pattern goes, it's going to do the same exact thing. In this particular case, it's just going to come down here and jump all the way down to one failure case instead of having many. So real quick, let's take a look at the code and what that actually looks like. Inside of the repo, I will go to the North Wing, and we end up having this pattern used, and I define this if-else steps, right? So if you want to compile this yourself, you compile it with ladders here instead of steps, and it'll generate the right code. This is gross and ugly. Like, this is not the type of code that you would want to do, but you'll be amazed how often you see this pattern and actually reverse engineer in other people's code. Like, you'll think, like, why would somebody possibly do this? Why would they repeat this, like, failure case and continue to do this all the way down here? People do it. It's just something that feels natural to them, I guess. I have no idea why. But it ends up that you'll see this kind of stuff, and this is the pattern, the sort of stairs that we saw. If we sort of take a lot of that extra fluff out and just say, if this, and then 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 have finally a welcome to the party, which will only occur after all of these particular points are actually hit, or have a single case, which you don't actually need an else because it falls through anyway, to this location, right? So this is that sort of ladder pattern. And again, if we take one if statement and I were to put name 0 is not equal to J and name 1 is not equal to O, and start doing this type of thing, it'll actually end up resolving and looking like this ladder pattern. So this is sort of the basics of what's actually going on and why we care about ladder patterns and step patterns. Hopefully this was useful to you. What we're going to do is reconvene in the next video and head into the South Wing to learn a little bit more about some other patterns. We'll see you then.